Now these next two sessions I think probably you will find rather easy. This textbook, the book by Sipser, starts out rather easily. I'd say probably junior level in the American system, and goes through senior and first year master's level towards the end of the course, and more advanced chapters. Well, I can give you. I'll just read out the chapter titles. So zero introduction. That's what we're doing at the moment. And remember, there are three parts. So part one on automata and languages. So the chapter titles are 1, regular languages, 2, context-free languages, and then part 2 on computability theory. Chapter 3 is the Church-Turing thesis. 4 is decidability. 5 is reducibility. And 6, this is where the reason I'm reading them out. So chapter 6 is advanced topics in computability theory. There's another chapter also starts off in the chapter label advanced topics in something something. So those two, so that's chapter 10, so the second one. So chapter 6 and chapter 10, they are definitely at M1 level, right? You may find yourself rather challenged by those levels sometimes. It's definitely pure math. If you don't like pure math, you probably will not like this course, right? So part 3, complexity theory. So chapter 7, time complexity. Chapter 8, space complexity. 9, intractability. You just can't do anything with a damn program. Okay. And 10, advanced topics in complexity theory. Okay, so a multi-level course, you might say. So these two sessions now basically on sets are pretty easy. I guess a lot of you will zip through this pretty fast. If it's been a while since you've done it, then just treat it as a refresher course. If you've never done this sort of thing before, these 2 sessions on sets and sequences and n tuples and so forth, I don't think you'll find it difficult. You just need to put a bit of effort into memorizing them if this is all new to you, but probably not so difficult. Alright, so we're talking about sets. Set theory is used a lot in computer theory, so basic. So we start off with a set. So from the end of the previous session, defined a set to be just like a bunch of objects, a bunch of things, a group of things. I tend to shy away from the use of the word group because group has a very technical meaning in group theory, which is a really important branch of pure mathematics. In fact, my very first course that I taught was on group theory, so I'm sensitive to that word. Okay, so I said just a bunch of objects, bunch of things, right? And a set can contain pretty well anything, right? Like could be a set of numbers, symbols, could be a set of other sets, right? Now the members, the things contained in the set, the members of the set are they generically get labelled, well, members. The members are members, right? Another word used is elements. So you can talk about the elements of a set or the members of a set, same thing. All right. So here's some words you need to memorize if all this is new to you. Now, if I do a double bar like this, what does that mean? It's just effectively like. It's sort of more than a period, more than a full stop. It's like a new thought begins here. It's just a separator. Like you'll notice there are very few spaces in my presentation style. And that's for good reason. You are probably watching this now on YouTube, right? Are you conscious of how long it takes to upload to YouTube? I've heard from YouTube people that every minute, about 2 days, like 48 hours of material, viewing material, is uploaded to YouTube. So 2 days per minute, okay? So YouTube is so swamped with stuff coming in, it has to limit the rate that its many computers can cope with. And so they deliberately slow down the upload rate, or from their point of view, the uptake rate. And it can take me, for example, when traffic is low, remember I'm in China, it can take me something like somewhere between 2.5 hours to 4 hours, sometimes 5 hours, to upload 10 to 12 minutes worth of filming. Okay, so I don't want to be uploading stuff that takes so much time if it's just blanks, right? It's just a waste. So my presentation tends to be fairly compact for that reason. I don't want to waste time, literally, upload time. There's so much of it. So I try to cram in as much as I can. And you can go full screen on your screen. So and I made mistakes in my first course, as I was not filming in high definition, and so I had readability problems. You couldn't read this stuff. But now, trial and error, with some help from friends, I learned to film in high definition and then compress, and that seemed to work fairly well. The readability problem, I hope, has disappeared. Alright, okay, so you can describe, you can write down a set in different ways. There are various ways to do that. One way is just simply to write out a complete list of the elements of the set. So usually the members of the element are written within like wiggly brackets, right? Often called braces. So a brace, or braces, is the wiggly brackets, or curly brackets, right? Like this. This is one way of writing a set. So here we have a set of numbers, a set of integers, and the three members, or three elements, same thing, 7, 21, 57, separated by commas, right? And the wiggly or curly brackets, or braces. So this is the beginning of the set, the end of the set. Okay, so that's one way to write a set. Now this symbol here, it looks like an epsilon, Greek letter, what, 5th letter of the Greek alphabet. In set theory, it's interpreted to mean belongs to. Okay, so for example, e.g., for example, 7 belongs to this set, right? So because 7, here it is, 7 is a member of, is an element of this set. So 7 belongs to this set, right? And does not belong is just the belong symbol slashed, crossed out. Does not belong to. Okay? So this number 8 does not belong to this set because it's not a member of the set. It's not an element of the set. Okay? So belongs to, does not belong to. Alright, what's a subset? Well, it's a smaller set of the set that you're talking about. So it has a. So say you have two sets A and B. So often you'll label a set by a capital letter. It's not strict, but a lot of people do that. It's fairly conventional. Right? So you talk about two sets A and B. Like this, you could label this as set A, for example. So you have two sets A and B. Now A, your first set, is said to be, by definition, is said to be a subset, like a smaller set, of B, and it's written this way. This is how you write it. So this looks like a capital C, and with a horizontal bar underneath. Now, the way my trick to remember which one's the set and which one's